So section 10.4 is going to work with matrices, and we're going to learn some skills with matrices in terms of adding, subtracting, multiplying by a constant, and then just multiplying matrices. The first one I included just because it's a foreshadow of some stuff to come in section 10.5, and because it's a problem on your homework. It says find values of A and B that make these matrices equal. Well, in order for these matrices to be equal, that is, if I want A equals B, then all their corresponding parts have to be equal. So in particular, that's going to give me that B has to equal 6. And what other number do I get out of this? Well, A equals -8. So nothing really big there. Just kind of have to understand what they're asking for. I can't say that this is going to be a test problem. You're going to see it in your homework, and I don't want you cursing me when you do the homework like, he never told us this. There it is. All right. But mostly what we're going to work on is multiplying matrices. Now, some algebra matrices. So there's a few things involved in that. And one of the things would be multiplying matrices by a constant and then adding matrices. Let's just remind ourselves real quick here. What are the dimensions of that matrix? Is anyone?
2 by 3?
Yeah, 2 by 3. And of course, A would be a 2 by 2. B is a 2 by 3 again. So let's take a look at a couple things here. And in particular, I'm going to start with 3 times A. 3 times A, now that's a constant times this matrix. And to do a constant times a matrix, that's kind of what you might expect. You're going to take 3 times -4, so I'll get -12, and then 3, 21, and 6. So there's your 3 times A. But then you're asked to add it to 2 times B. Well, let's take a look at the dimensions of this matrix. This is what size matrix? A 2 by 2. How about matrix B? Now, I don't know. I haven't calculated what 2 times B is yet. But B is what size matrix? 2 by 3. So they don't match. Now, if you don't trust me, then maybe you trust your calculator. I've already got these matrices programmed in my calculator. So let me just pull those out here for us. So second matrix, there's matrix A, and then here's matrix B. So I can do 3 times A plus 2 times B on my calculator. So second are 3 and then matrix A. But if I try and add them together, it's not going to like it because the dimensions don't match. And it's going to tell me just that when I try and do this. Let's see, I did 2 times A, sorry. Let's try that again. Let's try 2 times B. There we go. Yeah, it doesn't like it. It says dimensions mismatch. In order to add matrices, they have to have the same dimension. These don't, so okay. Let's see if the other ones do. The other ones in this part of the homework do. So dimensions don't match. Don't match. So we can't do this one. Okay. How about 3 times A plus 2 times H? Well, before we start putting these into our calculator, do you think we'll be able to do this? Will we be able to do 3 times A plus 2 times H? Yeah. The dimensions are going to match there. You're going to have 2 by 2 matrices. So let me remind you how to edit a matrix. Let's clear out this. So let's just quit, clear out that. Let's start by entering the matrices. So to enter in matrix A, second, and then matrix, you want to go over to edit first to enter in your matrix, and then tell it the size of your matrix, and type in each element of that matrix. As you type it in, say a -4 and press the enter key, it politely cursors you to the next spot that you need to enter. So -4, 1, 7, and 2. Once you have that, then you want to exit out. You want to quit. So you hit the second key, then the mode key to get out of the edit menu. Now, unfortunately, we're going to jump right back in. We're going to input matrix H. So second and then matrix 8. We want to edit that one. The tough thing for me is I always just want to press 8. But if you want to edit it, you got to go to the edit menu first. So go over to edit, then type in an H, enter in your matrix H. Matrix H is going to be another 2 by 2 matrix. This time it's going to be elements of 2, 1, 0, and -3. Let's try that again. 2, 1, 0, and -3. Okay, so looking good there. Now I've already calculated 3 times A before, so I don't necessarily need to do that again. But I can do this whole thing on my calculator. There's no real joy for me in watching you multiply it by hand. So let's see if we can't get this whole expression out of our calculator. So 3 times H. So we'll start out with the 3. And then I want matrix A. Plus, let's clear this out, plus, and let's see, we wanted 2 times H, so second 2, the inverse of the second and then the inverse button gives me my matrix menu. This time I want the H, so bam, there we go. So 3 times A plus 2 times H, that's going to be -8, 5, 21, and 0. All right, so -8, 5, 21, and 0. Okay, good. So that's this one right there. And last but not least, do you think we can do 5F minus 4 times G? Is that one that we can do? Are the dimensions going to line up okay for something like that? Yeah. Thank you, Stan. Let's put those in. Now this one here, matrix F, that one's kind of special. And we're going to see this again in section 10.5. But another name I call this is I3. It's what's called the identity matrix. You've got 1s on this main diagonal and 0s everywhere else. It's a square matrix, 3 by 3. That's why I call it I3. But for right now, we'll put it in as F. We'll also edit matrix G. Matrix G is going to be a little bit more involved. We'll start with F. I've actually already got F in, so I'm going to put in G. So for G, go over to the edit menu first, then type the number 7, enter in all the matrix elements for matrix G, and let you enter those in. If you're watching this at home sometime in the future, then, again, keep up with this and enter in matrix G. We also need to enter matrix F. Matrix F was just that 3 by 3 identity matrix, 1s on the main diagonal and 0s everywhere else. The one thing that you have to be careful of is that when you're done editing, so you're down here, you've put in all your elements of the matrix, you want to exit out of there. Hit the second key, then the quit key to get out of there before you edit your next matrix. F is my 3 by 3 matrix. There, my identity matrix. Let's see if we can't find 5F minus 4G. All right, so we're just going to type that in. And actually, I'll do it a little bit by bit. I'll do 5F to begin with. 5F should be pretty predictable. So instead of 1s on the main diagonal, you've got 5s on the main diagonal and 0s everywhere else. So you're just multiplying each element by 5. All right. And then from that, I want to subtract 4g. The nice thing is that you don't have to type this in again. You can just hit the minus key and do minus 4 and then matrix G, which would be 7. So there you go. It's going to take your answer from here and subtract 4g. And that's our answer for this one. So let's take a look at that. Let's see, or let me just write that down. So 13, negative 4, negative 32, negative 16, 5, and 40, 36, 28, 33. There's your matrix. Nice. Nice. So it's certainly nice not to have to do these things by hand. When I first started teaching OCC, not everyone had a graphing calculator. In fact, I was usually the only one in the class that did. So we had to do these things by hand, but I'm well past that. I'm okay with you guys doing these things on a calculator. I don't really want to see you do, menial arithmetic on an exam. Nice, nice. Comments on example B there? We okay with that one? How about example C here? Can I add these matrices together? 4 times matrix, this matrix, and then this matrix. Can I add those together? That looks like it should be a 2. I'm not sure if it printed clearly on yours or not. What's going to happen when we try and add these together? Dominic, is that going to work? Why not? Yeah, the dimensions don't match. So we can't. The dimensions don't match. Great, so we're kind of spared a little bit of work on that one. Now what we're going to edge closer to is multiplying matrices and using matrices to solve systems of equations. But we're not quite there yet. That's mostly in section 10.5. But let's take a look at this one. 2x plus a equals b. Here's your a and b. Those matrices are of the same dimension, so that bunch is good. Let's see what happens when we try and work with that. I'm going to kick this over to a new sheet of paper here. So we've got example D here is 2x. And to make this seem less like a variable and more like a matrix, I'm going to write it like this. I'm going to write like the Roman numeral 10. Okay. Now I want to get x by itself. And for the most part, you're going to treat this just like you would an equation. If you wanted to get x by itself, you'd move the a to the other side. What happens to that a when I move it to the right-hand side? Yeah, it becomes negative. Now with matrices, we don't typically think of dividing, but you can multiply by a number. And in this case, what would be that number that I would use to get rid of the 2 here? What? Yeah, 1/2. It's just the reciprocal. Thank you. So we're going to multiply both sides by 1/2. On the left-hand side, I get my answer, x. On the right-hand side, I see how to calculate it. It's going to be 1/2 b minus a. B minus a. Let's put in those matrices into our calculator. I know I can do the subtraction because those dimensions match. Yeah, those dimensions and the matrices match each other. So let's put in those matrices and see what we can get. So let's clear this out, clear that out. Matrix A. Go over to edit. This is going to be your 2 by 2 matrix. That's going to have elements of 2, 1, it's going to be, no, 2, 7, 1, and then 8. 2, 7, 1, and 8. And I think I can get away with this. I need to enter another matrix, so I can hit the second key, then the matrix key, and go over to edit. This time I want to edit matrix B, which right now is a 2 by 3 matrix. I need to change that to a 2 by 2 matrix. Its elements are 6, 8, 7, and 4. If you're a little unsure if you entered those matrices correctly, you can kind of print them out for yourself. If you just hit the second key, then the matrix key, you can type the 1 or press the number 1 to get, a look at your matrix. You can do likewise with matrix B, just to make sure that you entered those things correctly. Now the expression that I want is 1/2 of B minus A. So for the 1/2, I'm just going to use a 0.5. And I want matrix B minus matrix A. Are you getting the same thing that I've got here?
I can't even get out of my matrix thing.
Hit the second key, then the quit key at the top. So up at the top here, to exit, you're going to hit the second key, the blue key, and then the mode key next to it. If you look above mode, it says quit. So when you need to get out of a menu or something like that, that's what you do, is you hit the quit key.
And then how you get it on there?
So do you have the matrices entered? Do you have them both entered or just one?
I have them entered into the matrices part, but I don't know how to get them here.
So let me go through that one more time here. Let's type in a 0.5 and then parentheses. I want matrix B minus A. So you get matrix B, you hit the second key, then the matrix key. I want the second of those two matrices, so I'll just type the number 2. You could also cursor down and press enter. Minus, go back to the matrix menu. This time I want matrix A. And there you go. Still not happening? Did you enter in both matrices correctly?
I'm doing something else wrong.
Bring your calculator up here. Let me take a quick look. While we're doing that, take a look at this next part, and think about that next part a little bit first before we start entering things in. We're going to deal with matrix B and matrix X. Second matrix A.
Wait, what?
This isn't matrix A. That's why you're not getting the right thing. Matrix A. Let's edit it. Should be okay. No, that's okay. Let me try matrix B. Okay. So 0.5A. Actually, let's do this. Oh, it's B minus A. So let's do matrix B minus matrix A. Is that what I got? Let's take a look here. Yeah, that's what I got. All right, so does anyone see anything that can save us a little time in working with this one? So this is example E here. We're asked to calculate example E. 2 times B minus X equals D. What are the dimensions of these matrices? What's the dimension of matrix B? 2 by 2. How about matrix D? 3 by 2. It's row then column, right? So you're not going to be able to combine these things at all because they have a just different dimension. So we can't, the dimensions don't match. If the dimensions did match, then you could go through and solve for x. I'm not going to put that on the notes, but I will show you real quickly what it would look like if you could do that. You could distribute the 2 and get 2b minus 2x equals d. I would switch these. I'd move the d to the left-hand side, the x to the right-hand side, for two reasons. One is that it gets the x by itself, and the other is that it makes that x positive. And then you'd multiply everything by 1/2 and get b minus 1/2 d equals x. It's just that it's in matrix form, and if you had to solve it, then this is what you would do. But the big thing to see is we can't do that for this one. The dimensions don't match here. And the dimensions make a big difference. A lot of times, I'll kind of joke around about my corporate sponsor, my alleged corporate sponsor, because they haven't sent me anything. RC Cola. All right, yay. The reason I always joke around about RC Cola, Royal Crown Cola, is because the order that you list your matrices in is always row then column. Row by column. Always RC. And it makes a difference because if you're trying to multiply matrices, their dimensions have to line up in a very particular way. So we'll talk about that particular way as we move down our list here in section 10.4.
I just have a question. So the example d 2x plus a equals c, so that's the answer?
Oh, no. I don't think I wrote down the answer there. Let me go back here and do that. The answer to this one is 2, 0.5, 3, and negative 2. And the expression that I had there was how we calculate it. But this is the answer. Yeah, thank you. Yeah, so this is 1/2 of b minus a. Now you could calculate that without a calculator. You would just take matrix B, subtract matrix A, and then multiply everything through by 1/2. So you could do it without a calculator. It's just, why bother, all right? All right? That's why we have technologies. It's supposed to improve our lives, right? Okay. Let's talk about multiplying matrices. To multiply A, which is going to be an n by p matrix, with B, which is going to be a p by m matrix, 1, the dimensions, these inner dimensions, must match. The inner dimensions must match. Okay. And there's another peculiar thing about multiplying matrices. The dimension of our product is going to be this right here. So the size of the product is the outer dimensions. So those outer dimensions in this case are going to be n by m. So this is just kind of strange. It's like I said earlier, it's going to be different than what you're used to. So let's just look at a couple examples. Can you multiply A, which is 2 by 3, with B, which is also 2 by 3. So I'm going a little off script here, not entirely. This is really kind of example F, the first part. Okay, so let's see. Can we multiply those two matrices? Well, that's just down here. 2 by 3, this is a 2 by 3 matrix, and this is also a 2 by 3 matrix. In order to multiply these matrices, those two have to match. Do they match? No, they don't. So you're kind of stuck. You can't multiply them. The dimensions don't match. You can't multiply them. So you can't multiply these matrices. How about the one I have up here? Can we multiply these matrices? Well, what are the dimensions of this matrix? Dominic? Dominic A?
2 by 3.
All right, so I got a 2 by 3 times a what?
1 by 2.
A 1 by 2? No. Row then column. How many rows? 2 by 1. Can I multiply those together?
And the first one will be 3 by 2.
Yeah, the first one should be 3 by 2. Thank you. Can I multiply these together? Let me rewrite this here. And thanks, Lena. 3 by 2. Well, 2 equals 2, so yes, you can multiply them. The size of your product is going to be a 3 by 1 matrix. That's going to be the size of your product. Nice. Let's look at some dimensions one more time before we actually go through some of the nitty-gritty in multiplying those matrices together. So let's look at matrices M and N. So let's say M is a 3 by 2 matrix and N is a 2 by 3 matrix. Can I multiply these two together? Millie? What do you think? Can we multiply these together?
I'd say yes.
Yeah, we can. And what's going to be the size of the product when I multiply those together? And call that product maybe P. What are the dimensions of that product going to be? 3 by 3. That's going to be the dimensions of your product. But here's the weird part. What if I did N by M? We'll call that matrix Q. Go through and find the dimensions of the product here. So N is still a 2 by 3 matrix. So 2 by 3. M is still going to be a 3 by 2 matrix. Can I multiply these together? Yeah, no problem. These match. What do I get for the product? What size matrix do I get for the product? 2 by 2. Now, in your experience, when you multiply things together, the order doesn't matter. You can multiply 8 times 7, or you can multiply 7 times 8. You get the same thing either way. Is that true with matrices?
No.
No. You're getting completely different things. On the one hand, you're getting a 3 by 3 matrix. On the other hand, you're getting a 2 by 2 matrix, which is just bizarre. If you wanted to apply a fancy term to that What that means is multiplication of matrices is not commutative. You can't change the order like you can with multiplication of numbers. So what's going on with matrices? Well, let's take a look back at that second one in example F here, the one that we could do. And I'll show you that one as a starter. Now I'd like you to be able to multiply matrices in a very simple case. Certainly you should be able to check to see if matrices can be multiplied or understand why they can't. But let's look back at this one, 2, 7, 1, 8, and then 6 and 8. And I'm going to multiply that by 7 and 4. Now we already looked at this one. The dimensions lined up okay. So it was a 3 by 2 matrix times a 2 by 1 matrix, and that's going to give me a 3 by 1 matrix. So I'm going to write that 3 by 1 matrix here, but I'm going to leave myself a lot of room. So 3 by 1, that's going to mean I'm going to have a total of 3 entries. I'm just going to put this here to kind of keep them separate. You don't have to. But the way this works is that each of these cells comes from a product of the row of your first matrix times the column of your second matrix. So in this first example, if you wanted to call this matrix maybe C, then this is the first row and first column. Call it C11 maybe. Take the first row here times the first column here. That's going to be 2 times 7 plus 7 times 4. And I'll do the arithmetic for that later. But that's your first entry. Let me move down to this second spot. Now this second spot is going to be row 2, column 1. So I'll call that 2 and 1, C sub 2 and 1. And the only reason I'm putting those numbers here is to help you keep track of what you're going to multiply. You're going to take this row, the second row from the first matrix, times the first column of this matrix. So 1 times 7, 1 times 7 plus 8 times 4. What's this last cell called? What would its notation be here? C what? Well, let's see. This is the third row, first column. So I'll call that C31. So that means I want to take the third row of this matrix times the first column of this matrix. That'll end up giving me 6 times 7 plus 8 times 4. Okay, great. The rest of this is just arithmetic. 14 and 28 gives me 42. 7 and 32 gives me 39. And 42 and 32 gives me 74. And that's it. Did I miss did I make an addition mistake someplace? Now, multiplying matrices is not going to be the highlight of your math career in this class. Yeah. Liv's giving me a smile like that's an understatement. In any case, it is something that I'm going to ask you to do by hand on the exam, but just one of them. Before you throw in the towel of despair, let me do another example. We'll look through this together, make sure you understand what I'm asking for, and I'll also give you a nice little helping hand along the way. But are we okay with this first one? Is there something more that I can do. I always just put these here just to remind myself what row and what column that you're using to get this product. Okay, let's keep going with example G. And these problems tend to be long, so I'm not going to try and squeeze it all in here. I'm going to give myself a generous amount of space on a new page. So example G. A is 2, -3, and 6. 1, 5, and 9. B is 5, 7, -9, 18, 3, and 4. Now I'm going to give you the easier of the two jobs, which is to multiply A times B. But let's start out by multiplying B times A together. Can we even do that? What are the dimensions of these matrices? Blake, what do we got there? What are the dimensions of matrix B?
3 by 2.
Good. 3 by 2. What about A?
2 by 3.
2 by 3. Nice. Ethan, what product are we going to get? What's the dimensions of our product going to be?
3 by 3.
Yeah. We're going to end up with a 3 by 3 matrix. So let's call that matrix C. And that's going to be our 3 by 3 matrix. Now, to make this a little easier on myself, I'm going to draw a big 3 by 3 matrix. Here. And likewise over here. And I'm going to divide it up into thirds. So roughly maybe here. And then down below. But I want to make this a grid that's 3 by 3, so I need to split it up in a couple places. Here, about here is maybe good, and maybe here. So that's going to be a 3 by 3 matrix. And let's give this some labels. That's first row, first column. Lena, what's this next one? What should I write there? Well, this first one was first row, first column. Second one's going to be first row, second column, first row, third column, and so on. How about this one? What would this one be?
Second row, first column.
Keep going.
Second row,
Good. And I'll do the rest. C31, C32, C33. Now remember, it's always row then column. So when we're figuring out what to multiply, it's going to be the row from this first column, first matrix, times a column of that second matrix. That's why these indices have to line up so nicely, is so that you can match these things. So the number of columns I have here has to match the number of rows that I have here. And of course vice versa, depending on what order you're doing things in. Now, I'm going to reorder these things just so that I have a little easier time looking at them. So it's going to be 5, 7, -9, 18, 3, and 4, multiplied by 2, -3, 6, 1, 5, and 9. C11 is going to be the first row here times the first column here. So it's going to be 5 times 2 plus 7 times 1. Let's try the next one. First row, second column. Mag, can you help me out with that one? What should I multiply together to get these two?
7.
First row. So 5
Oh,
and second column
5 times 3.
plus 7 times.
Oh, times 5.
Is that a negative 3? Mm, yeah, it's a negative 3. Thank you. And then 7 times 5. Good. Let's keep going. Zandos. How about the next one? What should I multiply here? C13.
5 times 6 plus 5 times 9.
5 times 6 plus how many times 9?
5 times 9. Or 7 times 9.
Plus 7 times 9. Beautiful. Let's keep going with the second one. So C21, that's going to put a negative 9 and an 18 for this row times this column. So negative 9 times 2 plus 18 times 1. And then negative 9 times negative 3 plus 18 times 5. C23, negative 9 times 6 plus 18 times 9. And so on. See if you can't finish off these last 3. What terms are you going to put in there to try and find that product? Okay. So let's take a look at this last one then. It's going to be this row times each of these columns one at a time. So 3 and 4 times 2 and 1. And then 3 and 4 times negative 3 and 5. And then 3 and 4 times 6 and 9 respectively. Wow. I think the only thing less fun than actually doing this by hand would be grading it. Grading is such a pain. So I'm going to make it easier and better for both of us. I'm going to let you check your answers. How do you think we can check our answers? Let's just do out maybe a couple of these real quick here. So this one would be 10 plus 7. That should be a 17. Negative 15 plus 35 would be 20. And then 30 plus 63 would be 93, and so on. I don't really want to make you do all this kind of arithmetic by hand. All right, I just want you to show me that you can set these things up. So let's go to our calculators. Let's put in matrices A and B respectively. So matrix. Want to go over to edit. Let's enter or edit matrix A. That's going to be a 2 by 3 matrix. 2, negative 3, 6, 1, 5, and 9. When you're done editing that matrix, let's edit matrix B. And even though I have a little reluctance doing it, you can hit the second key, then the matrix key again. This time we want to edit matrix B. So go over to matrix or the edit menu, then down to matrix B. Matrix B is going to be a 3 by 2 matrix with entries of 5, 7, -9, 18, 3, and 4. If after you exit this menu, you're a little bit unsure, like, did I really copy those things right? You could do the matrix and just type them out. There's your matrix A. Here's your matrix B. So I think they're looking pretty good. The nice thing about your graphing calculator is that it understands when things that are next to each other, there's an implied multiplication. So let's take a look at matrix B times A. So matrix B and then matrix A. I don't need to put the times in there. If it makes you feel better, please, by all means, go ahead and do that. Bam. There we go. Is it looking like it matches what we had so far? Yeah, 17, 20, 93. You can check that the second row, first column works out because that's -18 plus 18. So, yeah, we get a 0 there, and so on. You get, what, 90 plus 27, so the next one should be 117. But look, just take the products from here. I need to see the setup this much. You know, if you actually did the arithmetic by hand or not, I'm not going to know. And frankly, I'd be just as happy to see you get it right. So use the product here. 108, 10, 11, and 54. So what I'm hoping is that these are kind of giveaway points. You can literally check your answer before you hand this in. So make sure you get them right. There's going to be harder problems on the test. So get the ones that are supposed to be easy, get them right. Get some points, bank those points. Let's set up a different one. Let's set up A times B. I promise that's going to be easier. Why is that going to be easier? Let's take a look at A times B. So this is still example G. A times B. Stan, what are the dimensions of each of these? I'll tell you what, I'll put the dimensions here. You tell me the dimensions of the product.
2 by 2.
Yeah, you're going to end up with a 2 by 2 matrix. Nice. So just to distinguish that, I'll call this one matrix D, just for some difference here. And D, you're right, that's going to be a 2 by 2 matrix. So when I write these things next to each other, I've got 2, -3, 6, 1, 5, and 9, multiplied by 5, 7, -9, 18, 3, and 4. And all I get from this is going to be a 2 by 2 matrix. Now I am going to give myself a generous amount of room to write that 2 by 2 matrix. Let's do the same thing we did before. Let's kind of subscript this. This is first row, first column. Try and subscript the rest of this. And then see if you can't multiply these things together. Come up with the rest of it. My patented pause button. times that, this times this times this. Yeah. All right. So let's try this again. D11, that's going to be first row from A times the first column from B. Now times is kind of in quotes because it's really a series of multiplies and adds. So it's going to be 2 times 5 plus negative 3 times negative 9 plus 6 times 3. Nice, so there's your D11. You're going to take first row times the first column. Let's try this next one. That's going to be D12, first row, second column. First row, second column. Lena, you want to read that one off for me? What times what?
2 times 7 plus negative 3 times 18 plus 6 times 4.
Nice. Nice. Let's keep going down here. What are these elements going to be made of? Well, it's going to be D21. So D21 is going to be 1 times 5 plus 5 times negative 9. And finally, 9 times 3. 9 times 3. Last one, that's going to be D22. Second row, second column, so we're going to get 1 times 7 plus 5 times 18 plus 9 times 4. Nice. You write this down. Then if you want to finish up the rest of it with your product, that's fine. The one thing that I would caution you against is not faking it, because these numbers should actually match your product. So I get kind of unhappy when when I see that those don't. But let's do A times B, second matrix, A. Let's see, I can do this. I'll hit the times key and then matrix B. How about matrix B? Second matrix B. There we go. 55, negative 16, negative 13, and 133. 5, negative 16, negative 13, and 133. Nice. Okay, there's your product, A times B. I'm not sure I really want to do a lot more than just that in terms of multiplying matrices. It's not going to be a huge problem on the test, but it is, you'll get a small one just to show me that you understand its process. And certainly you should understand how the indices line up, how these dimensions line up, and if you can multiply or not. Let me pause for a second. Are we okay? Is there anything else you'd like me to say about that last example there? Let's flip over to this. This is kind of an interesting question. It says, which of the following operations can we perform for matrix A of any dimensions? Now, if it's any dimensions, then that's going to mean dimensions aren't necessarily equal, just m by n. Now, if it's a square matrix, that's kind of cool, but what if it's not? Can I add two matrices together if they have the same dimension? Can I add A plus A if they're each n by m matrices? Yeah. We're okay with that one. How about multiply a matrix by a constant? Can I do that independent of the size of the matrices? Yeah, we're okay there. How about squaring the matrix? What do you do when you square something?
Times it by itself.
Times it by itself. Can I multiply it by itself if I have each of these as an n by m? You can't. I heard somebody say you can't, and you're right. The only time you can square a matrix is if the dimensions are actually square. So let me show you how to square this one on your calculator, because this is not an operation that I want to do by hand, nor would I ask you to do something like this by hand. So let's put that one in, and I think you'll kind of like this once we get the matrix in. Edit matrix A. I always do that. I always get a little too anxious and I forget to move over to the edit key. The dimensions are going to be 3 by 3, and our entries are going to be 0.4, 1.1, 2.4, 0.7, negative 0.1, 0.9, negative 0.7, 0.4, and negative 0.8. All right, so a lot of stuff to enter in there. That's good. Once you've got that entered, exit out of this. We want to do a squared. Now, one temptation is to say that's a times a, and that's fine. Nothing wrong with that. But let me remind you that you've got a square key here on your calculator. So once you type in the matrix A, let me just show that much as well. To get the matrix A to come up on your home screen, hit the second key, then the matrix key. Then simply type the number 1. Now hit the square key. Bam. There you go. That's the square of your matrix. So pretty nice. One other thing I want to mention here, if you don't have a calculator or if you're not really comfortable with it, you might find it a little easier to work some of these problems on Desmos. Now, I don't have a version of Desmos that I can let you use on your phone during exams, but if you go to desmos.com, yeah, here it is, desmos.com, and then follow it up with /matrix. It's not making that bigger. That's kind of a bummer. Follow it up with matrix, and it takes you to something like this. And you can put in these matrices. You can type new matrix, then give it its dimensions, 3 by 3. Then type in all these things, 0.4, 1.1, 2.4, and so on. I should be in this matrix here. So 0.4, 1.1, 2.4. I keep on exiting out of the matrix. Sorry about that. I'm just going to fill this up with some other random variables. But you can square matrices this way. So once I've got that matrix entered, I could do things like, let me get rid of these lines here. Enter. You can do a squared, for instance. Okay, that's kind of nice. You can do other things like this inverse button. We're going to need that later on. There's some other things you can do that we're not going to touch in this class, like the transpose of the matrix and reduced row echelon form. Okay. I think that's all I want to say for section 10.4. Comments or thoughts on this? So the things you're responsible for from this section is being able to multiply matrices, understand, when you can multiply matrices, what the size of the matrices are going to be, if you can multiply those matrices. And then on the flip side of things, you could get something like this. This is meant to be an easy problem. I don't think I saw anyone struggling with it when we went through things. You're just going to have to remember what to do for something like this. It's not the hardest problem you're going to face on your exams. So where did that one go? That one. Yeah, right here. Yeah, you're just going to solve this algebraically. Once you get x by itself, then you're going to punch this into your calculator and finish solving it on your calculator. I'm only going to ask you to do one thing by hand, and that's going to show me that you understand how to multiply matrices by hand in one instance. But that's it. So good luck with that. And if it makes you feel better, there's this new thing. Have you ever seen it? A QR code. It's kind of a new thing. Yeah. But QR codes, that's just a matrix of numbers. Some of your old-fashioned methods of storing pictures are like bitmaps. And I think those were basically a matrix of numbers as well. So lots of applications for that, and that's where we're going to stop.